Welcome back to our YouTube channel Technology Tutorials. This video is the second part of our replica set and deployments video. In this video we are going to explain the deployments part. In this video I am going to show you the basic functionalities of deployment, the theoretical part of which has already been explained in part 1. So if you want to visit that, please check the link in description box. Okay, so now before moving to deployment, where we'll only explain the basics of deployments, because it's a vast topic, it's a very important topic. We cannot cover it in one video, it will be too long. So we'll cover the advanced deployment topics in later videos. Before we move with the hands-on of the deployments, let's see how we can benefit from deployments. Many of the features that deployment provide are already provided with replica sets, like scaling up of pods and monitoring of the pods to ensure that minimum number of pods are up and running. So here in this cluster we have one replica set and two pods spawned from that replica set. Let's describe the replica set and check the configurations. So here you can see the image version is 1.16 and the same thing will be there for the pod as well. Here also you can see it's Nginx 1.16. Now if I need to update the Nginx image version to 1.17, can I do it with a single command or do it online without deleting the replica set? Let's try. Right. If you remember, the container name was Nginx web. We are going to set it to 1.17. Okay. Now you can see it is saying the image, replica set image has been updated. Here we can see it is saying the replica set, demo replica set has been updated. Now the replica set has spawned two pods. So let's see if those pods have also updated with the latest image or not. Before that, let's describe the replica set. Here you can see the Nginx version 1.17 has been set. Now whether the pod is automatically updated or not, let's see. Let's pick one of the pod launched here. So see, the pod version is still 1.16. So replica set cannot automatically update a pod or terminate a pod and recreate a new pod with a new version. So this functionality is provided by deployment. Now we need to see if there is a way to get the pods up and running with the latest image. So for that, what we need to do in replica set, we have to delete the existing pods and wait for the new pods to spawn. Then we can check whether the new pods are created with the latest image. We can see that one of the pod is created just 7 seconds before. Let's describe this pod and see the image version. So here you can see the image has been set to 1.17. So if you have a replica set created separately in your cluster, then you have to manually delete all the pods that are already running, and then replica set will make sure that the updated configuration is applied to the newly created pods. This is the major benefit that deployment provide over replica sets. And in this video we are going to demonstrate that. For that, what we will do, we will delete this replica set and create a deployment. Now we already have this deployment YML or deployment manifest already created. So let's see how it looks like. This is the one. So here we are again using the Nginx web name, and the tier we are providing as front end. Now for this video we are putting the image version as 1.14.2. Now let's apply this manifest. Now we'll apply this deployment here. Our deployment is created now. Let's see how many pods and replica set it has created. So for that we run kubectl get all. So you can see the deployment Nginx web is created with 2 pods which are ready. It has already spawned a replica set. Now look carefully. The replica set name is starts with the deployment name and then the unique hash value assigned by the Kubernetes, and similarly the pod name will also be the deployment name and the unique value of the replica set and the unique value of the pod. But you can consider it in the same way as was explained earlier, that it's a replica set name and the unique value of the pod. Now let's check on the automatic application management of the deployment. Before setting the new image, let's check on the existing image set in the deployment. So it's Nginx 1.14.2, right? And now let's update it to 1.16. Right. So our now we have to find our container name. So for that, here you can see it's Nginx web. So this will be equal to, and if you want to record this change, you can put record equal to true. For now we'll not put this. We'll show you how it looks like. Now you can see just now the 2 pods are created, 6 seconds and 4 seconds. So the 2 new pods are spawned by the deployment, and you can see one of the replica set is having 2 capacity. That is a new replica set that has been created by deployment, and another replica set is now having 0. So this is the old one which was running for 2 minutes 40 seconds. Now let's describe the deployment and check if the image has been set correctly. So here you can see the image is Nginx 1.16, which is updated one. Now you can also check the replica sets. Okay, you can see the Nginx one of them, the old one which was created earlier, is having the old image version, and the newer one is having the 1.16 version. Now what we can do, we can check the history. So it is saying it is successfully rolled out. Now instead of rollout status, we put history. We will see there are 2 revisions, 1 and 2. 1 was the original one, and then 2 has been created. Now let's do a upgrade to Nginx 1.17. So for that, what we'll do, but this time we will record the change. Okay, so see, earlier we had used the name in this way, you can see, but we can also put our use the deploy and Nginx web, and then put Nginx, the container name, and then the image version. So 1.7. and what just my mistake. So let's do one thing, kubectl. This is so we did not record the change, but we wanted to record the change, right? So for that we can roll back the deployment, but before that let's see what is the status of the deployment. It should have a new revision. See, 3. So you can keep the history here. Now we need to roll back because we had not recorded our change. So what we'll do, we'll undo. Okay, now if we go, you will see another revision has been created, but the image version has been rolled back to the Nginx 1.16. so let's see. See, 1, 3 and 4, these are present now. Okay, the version 2 is not there. So let's see. See, the image version is rolled back to 1.16. Okay, so you can see the revision, it is showing as 4. Okay, let's record this change. So record the change of our upgrade. So for that, what we can do, we can use record equal to true. Okay, now let's see how it looks like now. Now you can see earlier in our describe, see, this was the annotation section, only revision 4 it was showing. Here you can see it is showing as revision 5. Obviously this is automatically updated, but what command we executed, the change cause has been added here because we have put record equal to true. Okay, now let's see. You can see it has the set image as a change cause. If you have noticed that when we did rollout undo and we upgraded our deployment with version 1.17 with the record equal to true, version 2 and 3 were removed. So this is because that when we did rollout undo, that means it went from version 1.17 to 1.16. So the version 2 was already with 1.16. So what it did, it upgraded that change into version 4 and removed the version 2. Similarly, when we did the upgrade to version 1.17, it removed version 3 which was already containing the change or deployment upgrade of 1.17, that history it contained. So it removed that one and created a new version 5. In this way, it checks for the duplicate changes and efficiently manages the rollout history. Next, we will scale the deployment. So deployments can be scaled in two ways: manual scaling and auto scaling. First, let's check the manual scaling. Okay, so here what will happen, we'll use kubectl scale command, and then we'll put the deployment along with the replicas argument, so that we'll provide the number of replicas or the number of pods that will always be maintained. So this is known as manual scaling. Okay, if we check the status of the deployment and what all objects have been created, so here you will see that there are 5 pods that has been created, and there will be one replica set which will be having the desired 5 replicas, and the remaining 2 old replica sets will be scaled down to 0 replicas. Now let's do the auto scaling. So for that we need to use kubectl auto scale command, and you need to put a minimum number of replicas and the maximum number of replicas, as well as the indicator, that is whether it is based on CPU or memory percent. Here we are taking CPU percent, and we'll try to keep it very low, 35%, but still, because we don't have any specific load on these pods, so we may not see any scaling of the replica set, or in other words the deployment. When we auto scale a deployment, it creates a new object, horizontal pod autoscaler. So here you can see it is showing horizontal pod autoscaler Nginx web autoscale, and also we can use kubectl get HPA to know the horizontal pod autoscaler that has been deployed. You can see there is a Nginx web HPA deployed, which has a target of CPU percentage 35, as well as minimum pods and maximum pods at 12, and the current replicas is 5. So how this scaling will happen: when the pods that are currently running will have CPU percentage more than 35%, then a new pod will be spawned, so that it is able to support the required load. We will demonstrate this HPA part in a later video. We can also pause the deployment so that accidental changes to any deployment can be prevented. So for that, what we can do, we can use kubectl rollout pause command to pause the deployment. So let's check that. For that, first let's see what are the revisions we have. We have 1, 4 and 5. Now we will use kubectl pause command. Next we need to test whether this pause is working or not. For that, we will set the image version to 1.18 using kubectl set image command. Now let's see if there is a deployment revision created or not. Here we can see that there is no revision created, so that means there is no image that has been set to the deployment. This we can confirm by checking the replica set. We can also see that there are no new replica set that has been created. If we check the image version, we can see that the latest image version is 1.17 only. So 1.1 has not been deployed. This is because we are using kubectl pause. Let's clear the screen and then we'll try out the resume option. So there is also an option to unpause a deployment so that we can deploy the new changes. So for that we need to use kubectl rollout resume. Now next we need to set the Nginx image to 1.18 and see whether the changes are reflected. So here you can see a new replica set has been created. Okay. Now if we want to check the image version, we can use override and see that the latest image version 1.18 has been applied. The last command that we will be demonstrating in this video is how to delete deployments. So for that we can use kubectl delete deploy or deployments and the deployment name, and if you need to provide the namespace, then -n and the namespace. You can see the deployment has been deleted. This concludes our deployment basics video. Thank you all for watching.